In this video, we're going to learn about Pearson's R, or Pearson's product moment correlation coefficient. And Pearson's R is one of the common or standard statistical tools to determine if there is a significant relationship, or there are significant relationships between bivariate data. So in the last video, we have learned chi-square test of independence. Here, I'm going to present Pearson's R here. And to start with, let us introduce the test. This is used to answer objectives of this type. So very simply put, if in your statement of the problem, or SOP, you have this specific objective, is there a significant relationship between variable 1 and variable 2? Pearson's R is one of the statistical tools that can answer such objectives. And this is a measure of linear relationship between two variables. And I want to highlight that it's linear and it's only a relationship. And I just want to highlight that, and or to recall that having a relationship does not mean causation, or correlation doesn't mean causation, as the common maxim states. Just be careful when stating your conclusions, because when you say that there is a relationship, it doesn't mean that the cause of this variable being high or low is not the other variable. So it doesn't determine the causes. Okay, only telling that there's a link or there's an association between two variables. So be careful in your conclusions regarding that. So what are the assumptions of Pearson's R? This test could only be used for at least interval data, that is interval or ratio only. In short, it should be quantitative in nature. The type of variable should be quantitative. The two sets of measurements, bivariate data, meaning bi means two, so there are two variables that we're correlating, are taken from each subject or each participant of the study. And there must be an existence of a linear trend. This linear trend is one of the assumptions that is always forgotten by most researchers, and we want to highlight that there should be a linear trend before using Pearson's R. Um, how do we determine the linear trend? We first need to construct a scatter plot. A scatter plot is a graph plotted of plotted points that show the relationship between the two variables that you have, or the two sets of data that you have. It consists of a series of points plotted on the Cartesian plane, and each axis represent one variable, and samples of scatter plots of the points are shown on the next slide. So one example would be showing linear relationship. And on the first part, on exhibit A here, we can see a negative linear correlation. That is, as one variable increases, the other variable tends to decrease. Now, um, maybe you can recall in your algebra, this is where the slope is negative. So when the slope is negative, it's going downward. Similar logic or concept as this, or idea, and with correlation, it also tells you the same thing. So when you have a measure of correlation, it's more or less, if we're going to imagine that on a Cartesian plane, it is similar to the slope. So as well, we have a positive linear correlation. As x increases, y tends to increase. So those are linear relationships between two variables. I'm going to show you what does it mean when there's no correlation. Firstly, a perfect correlation. Let me go back a slide here. A perfect correlation means that you can trace the lines. Here, you can just imagine a line going upward, and that's where the correlation starts or exist. If there is really a line that the dots really create a line, a literal line, that's a perfect correlation. So the correlation is really perfect. When you mean, or when you say that there's no correlation, you cannot actually draw a line anywhere. So exhibit 3 shows it here, and exhibit 4 is nonlinear correlation. So you can trace a line, but it's curved. It's not linear, so therefore this is beyond our scope. But know that there are correlations that may be nonlinear, and again, beyond the scope of this video. And remarks of Pearson's R. Pearson's R, by the way, is just one number. It has a long formula, which I will not show it here, because maybe you'll get confused with the formula. But it's a common one. It's a long formula. But what we're gonna do in this videos, actually in the next video, I'm gonna show you how to solve the Pearson's R without using the formula. That is, we're gonna use a statistical software. And we have two bullets here. The R value is within -1 and +1 inclusively. That includes -1 and +1. The -1 is a perfect negative correlation, and the +1 is a perfect positive correlation. The value of the sign of R could generate the following information. One is strength. So the value of R means the strength. The closer you are to 1, either positive or -1, the stronger it is. And the closer you are to 0, the more weak the correlation is. If you have, again, per -1 and +1, and your correlation is exactly that, that's going to, we call that a perfect correlation. And when your R value is exactly 0, we call that no correlation, or there's no association between two variables. Imagine the graph in exhibit 3. The direction is determined using the sign, positive and negative. If it's positive, it's a direct relationship, indicating that as x increases, y increases, is similar to the concept of a slope. If your slope is positive, as x increases, y increases. Similarly, we have a positive r here, which makes it a direct relationship or positive relationship. If your R value is negative, it implies an inverse relationship or indirect relationship. So similarly to your slope, it's going to be negative. So as x increases and y tends to decrease, vice versa. If x decreases, y tends to increase. So um, what I can say with this R value is that it's a powerful metric. It's a powerful measure because given a single value, you can determine two information regarding the set of data that you have, which makes it one of the most useful statistical uh, tools there is. So, uh, just a remark, I have mentioned this before. Uh, Pearson's R measures bidirectional relationship. So, in this case, you don't actually need to determine independent or dependent variable. It really doesn't follow in this type of test because it measures bidirectional relationship. And this means that the choice of x and y is arbitrary. You can choose either of them because independent and dependent variables is not regarded in this type of test. So I simplified the procedure, and we just need to recall that how do we run the procedure? We have number one, state the alternative and null hypothesis, the alpha level. Two is run the test using a statistical tool, determine the p-value. Decision rule, you compare the p-value that you have in the alpha level, which is usually 0.05, and lastly make the conclusion. And I'm going to show a first example, but I'm going to reserve this to the next video so that it will be in chunks. And yeah, that will be it for this video. Thank you very much for watching, and I'll see you in the next.